Okay, good evening, ladies and gentlemen. Let me just settle down my camera. Okay, super. Okay, good evening and welcome to this live session on Lean Six Sigma. And we are going to learn something fundamental today. And it's going to be very interesting. Good evening to everybody. All right, let's welcome the new members first of all in the room right now. If you are attending the session first time, live session first time, just type me in the chat box. First, we will welcome you and then we'll start the session. That's our ritual. Come on. Let's type me in the chat box. If you are attending the session first time, just type me or I, whatever. And, in advance, we are just, typing welcome. Super. Everybody. Just type welcome, guys, in the chat. Welcome the new members. Okay, somebody, August. Who is August, by the way? Okay. Yes, yesterday was yellow belt session, but this is where your journey begins. Okay, super. Welcome all new members and welcome to this community. Uh, every Monday and every Saturday we connect in the evening. There will be hackathons in the first week of the month as well, where also we'll connect and go deeper into the concept. See why, let me just give you the context. Earlier, there were no live sessions. Then we started the question answer sessions once per week. Okay. Then after that, we started with some concepts. Then rather than only just question answer, we'll take one concept, go deeper into the concept or a case study or Minitab exercises so that the journey began. And then at the end of the session, we have the live question answers. Then later on, we started 2 days in a week. So one on Monday, other one on Saturday. So we only had Saturday earlier, but then we started on Monday as well. And we record this. And if you are not available in the live session, you can check the recording as well. Okay. So recording is available in the masterclass archive. All right. Yes. So let me just type this. So for the new members, masterclass archive is the, in your LMS system, you will find this live masterclass archive folder where you can find this recording. Okay. Now, this is the number, which is the admin. This is the SNG mentor number. Please save this number on your WhatsApp mobile, and wherever you get stuck in your entire journey, right from yellow belt level till master black belt or the consulting business launch, whichever level you are in, wherever you get stuck, just send a WhatsApp message to the mentor and we will be there to guide you. Okay. Everybody all set to start? Just give me yes in the chat box, all the new members especially. Super clear? Chalo. So आज थोड़ा सा हम लोग deeper into the concept जाते हैं. We will start the session is about how do you calculate your sigma of the process. Okay. So because we have people from all the industries, we have IT people, we have BPO people, we have bankers, we have insurance people, we have manufacturing, oil and gas, aviation. So we have people across all. So if I take one industry example, that will be difficult. So what generally I do, I take a general example, which is common day-to-day life example, and then you need to connect with your own industry. All right. So in this case, we will take a case of a tea stall vendor. Okay. Now the tea stall vendor is just a second. The tea stall vendor wants to improve his sales or improve his customer satisfaction. Okay. So generally in this tea stall vendor case, what are the major contributors typically, which will contribute to the satisfaction of the customer? Let me ask you this simple question. Let's say you are a tea stall vendor. Okay. What are the major contributors or which factor will satisfy the customer? Type in the chat box. Very good. Very good. Super. Taste is there. Cost, or I would say the price. So jitna sasta utna acha, right? Okay. What else? Type in the chat box. Taste, cost. What else? Imagine a tea stall. Temperature, amazing. Quality, very good. Now, let's just break the quality into various aspects. Break the quality. Now, when I say quality, I can say taste, I can say hygiene, I can say temperature also can come in the, right? Very good. Super. Now let's ask this question. Whatever, whatever points you have mentioned, can we measure them? Let's ask the question. First of all, let's talk about test. Test. Can we measure test? Yes, no, everybody. Just give the answer. This is an interactive session. Okay, everybody interacts. Can we measure the test? How do we measure the test? If I ask somebody, do you like it? Somebody will say, no, I don't like it. And if other person will say, I like it. So how do I measure it? Ah, very nice. Super. I can take a rating, right? Correct. So can I take a rating on the scale of 1 to 10? If I like it on the scale of 1 to 10, how much? If somebody says I like it at a scale of 1 to 10, 6. Somebody said 9. There's a difference, right? Both are liking, but somebody said I didn't like it. What is your rating? 5. Somebody said I didn't like it. My rating is 1. See the difference. But on the scale, now we have some number attached that will give a little bit of objectivity to it. It was subjective, no? Yes or no? Subjective. Right? Now that subjectivity has been converted into rating. Can we do the same thing with hygiene? Yes. Can we do the same thing with the overall experience? Temperature, of course, we can measure with the help of thermometer, degree centigrade. That is something which we can measure, right? Now, this measurable aspect, what we are dealing with, okay, imagine, let's say test hai, temperature hai, and hygiene hai, etc., etc., etc. Okay. Now, let's say test, we collect the data, and the data is saying that average test is around 8 out of 10. Okay. Now comes back to temperature. Temperature rating. Let's say imagine while collecting the data from the temperature, coming the feedback from the temperature, we can take it on the rating that how about the, is it hot enough for your satisfaction? Let's say people say, no, it is not. It is only 6 out of 10. Okay. And on the scale of hygiene, let's say, for example, just a second, just give me a second. Okay, is my voice clear, guys? Is my voice audible to you? Just give me a quick yes. Okay. All right. All right. I just found it a little less today. Okay, good enough. No, it is audible, right? Okay, very good, very good. Okay, coming back to, let's say, hygiene. Now, hygiene says, okay, people are happy with hygiene. Now, these three are called as, write this down, CTQ. Everybody just type CTQ in the chat box. So customer is happy with test, happy with hygiene, but not happy with temperature. What is CTQ? Very nice. Critical to quality. What will satisfy the customer, which will be measurable? These attributes are called critical to quality attributes. Are you understanding this? Yes? Now the same goes with almost all the service. Now we use Ola and Uber, right? The cabs. Now, when you book the cab, you get the driver's rating given by the previous customer, the average rating. Yes or no, everybody? Do we get that rating? What is that? Yes, when we book the cab, we get a rating of the driver, right? So what is that? That rating has been given by the customer on the scale of 1 to 5. How was your experience? So that experience, again, experience is a subjective thing. They have converted that subjectivity into objectivity by converting into a rating. And the system calculates it and gives you the average. Okay, yes, exactly, the star rating. Correct? Now, a lot of people are not aware. Some of the senior members are aware about it. The moment you get down of the cab driver also gives you the rating. A lot of people are not aware about it. Oh, is it? Now, another thing which a lot of people are not aware, let's say, for example, let's say Dhiresh Patil has a rating of 4.9 given by the drivers, no? Given by the drivers, and there is somebody called X whose rating is 4 out of 5. Now, when Dhiresh comes, let's say from airport to the residence, and he's standing in the queue, Dhiresh will get a preference because his rating is better. Even Dhiresh can get a better rate deal as well. Let's say somebody will get 600 rupees for the same distance. I might get 550 rupees. Are you understanding? This is how the algorithm is built. So preference priorities also can be decided by the rating system. Coming back to critical to quality, can you write one critical to quality attribute for your product or service and type in the chat box quickly? One, which is for your product or service, whichever organization, whichever industry you're working. Just give me one critical to quality attributes which is useful for you. Very good. Color. Okay, fantastic. Okay, can you just write your industry as well? थोड़ा सा industry भी बता दीजिए ताकि we can connect. When you say color, now it can be applicable for a pharmaceutical. It can be applicable for quick commerce, customer rating. Okay, sheet metal. Okay, sheet metal industry. Okay, got it. Color in the sheet metal industry, you're saying. Fantastic. Assay in the drug product, very good. That's a very important critical to quality attribute. Garment export, okay. Material handling, load holding pressure, very important CTQ. Load holding pressure. Yes, just give me one. So that concept should be connected with your own process. Okay, try to connect the concept with your own process. If that connection happens, then your understanding will go deeper. Clear, everybody? Super clear, eh? Now, so let's say if an area needs to be improved, let's say, for example, would be temperature. Okay, would be this temperature, right? So this is the area which needs some, because let's say test is doing okay, hygiene is also doing okay, temperature is where, this, what you can say, that the temperature is where they need to improve. Now, so they will take up a project on temperature, what you can say. So they have to serve a very good hot refreshing cup of tea. So they will take up a Lean Six Sigma project on temperature improvement, or what you can say, that average rating has to go up. From 6, maybe it has to go to 9. So now what we will do, we will collect voice of customer. What is that? Voice of customer. What is voice of customer? VOC, which is voice of customer, which is data collected from customer, which is feedback, data, complaints, whatever, right? Data from customer. Even this taste, hygiene, temperature is also basically we have collected from the customer. The rating we have collected, and that data is called as voice of customer. And this taste, temperature, hygiene, these are called CTQs. Are you clear? Data from customer is called voice of customer. Okay. And there is another term which is called voice of process, which is exactly data collected from process. Now, voice of customer is a vague terminology. Just try to understand the concept, okay? Let's say when I give the cup of tea to the customer will say, no, this is too hot. Or he or she will say it is too cold. It's a generic terminology, generic feedback you will get. Now, how much is too hot and how much is too cold, we don't know unless and until we collect some data from it. Okay, so imagine what we will do. We will we'll check the temperature of the cup, give it to the customer. Customer will give three feedbacks. Okay. What are the three feedbacks? One will be okay. One will be too cold. And one will be too hot. There will be three feedbacks. Okay. So customer sips it, says, okay, this temperature is okay for me. Are you clear? Huh. It can be cooled down. Yes, exactly. Too hot के लिए कोई complaint नहीं करेगा. That's true. Anyway, but just understanding the concept. All right. Now, imagine, let's say, if we give 100, 100 data points to the customer, 100 cups, okay, to the 100 different customers. Some of them will say it is okay. Some of them will say it is very hot. It is, burning my mouth, etc. Somebody will say too cold. Just try to understand the concept. All right. Now, when the people are saying, okay, we are checking the temperature. When they are saying too cold, we are checking the temperature. When they are saying too hot, we are checking the temperature. Now, imagine if the temperature is, let's say, 70 degrees centigrade, below 70 and below, they are saying too cold. Okay. And if it is going beyond 90 degree, they are saying too hot. Just for our sake of understanding. Are you understanding? So after collecting the data, we will understand, okay, so these are the boundary lines. Within this, customer is saying, okay. Are you understanding this? Just give me yes in the chat box. Clear, everybody? Just give me yes. Very simple example. So I've given it to the customer and I've just collected the data, and the data is saying, okay, between 70 and 90, customer is accepting this. Customer is accepting my product. And this is called as voice of design or specification limits. Who decides specification limits? Customer decides specification limits. Everybody with me till now, just give me yes in the chat box. सबको समझ में आ रहा है? Just give me yes. Very good, very good, very good. Now, anybody who has not understood this, please let me know in the chat. Don't worry, everybody's typing yes, yes, does not mean you have to say yes. Okay, you can say no, I haven't understood. So I will repeat it for you. Don't worry. All right. I have taken a very simple example so that it's a day-to-day example. Everybody can connect with it very easily. No technique, no technical, right? Yeah. Let me know which part you want me to repeat. Which part? Specifically. Voice of design. Now, have you understood the customer is not accepting below 70 degree because it is too cold for them, and above 90 degree, which is too hot for them. So we have got a range which is 70 and 90. Yes, you have understood till now? So 70 and 90, just give me yes. All right, yes. So this is called as specification limit. In Six Sigma terminology, it is called as voice of design, because now we have to design our process within 70 and 90. Now that tea stall vendor has to make sure that customer gets that cup of tea within this limit of 70 and 90. Are you understanding? Yes. So for example, like let's say, for example, if it is distance between customer and tea stall vendor, there are in some of the areas, people just give the order and just go a little farther for smoking. Yes, because chai and sutta go together, right? So now let's say distance is high, so they need to make sure that it has to a little boiled so that it should not drop below 70. Okay, so those kinds of stuff they have to basically adopt. Right? Clear, everybody? Very good. Yes. So this is the temperature which is customer will accept 70 and 90. You can say that the target should be 80 so that we will have a range of 20, 70 and 90 degree. Okay. Now what they will do. So the next part is, so I'm just removing this. Now we will collect the data. Okay. Because we want more satisfaction in that temperature part. People are not happy with the temperature. So we want to have some improvement. Because now first we have what we have done. We have collected the voice of customer. We have set the specification limit according to that. Now we will start collecting the data. Okay. Everybody just pull out your calculators. Just pull out your calculators. Simple. Your mobile calculator also will do. Now we will collect the data, and from the data, we will calculate the standard deviation of the data. Okay? Yes? Somebody is scribbling. Just a second. Let me remove this. Okay, so everybody please pull out your calcs and we will start our this one. Okay? Okay. Now imagine if I draw a distribution, data distribution like this. Okay. Anything which goes beyond 70 degree and 90 degree will be rejected by the customer. Okay. So we want everything within that limit, right? So ideally what we should be doing, we should be reducing the variation and make the process like this. Yes, everybody understood? So we have to reduce the variation and bring the process well within the specification limit. Correct? Everybody understood this? How can we reduce the rejected part? We have to reduce the variation of the process and bring the process in the center. Correct? Now, what parameter will tell us this? For example, let's say a bulky fat person wants to become a slim and trim. Which parameter will tell that person that okay, you are on the right track? What will be that parameter? What that person will measure? No, make it simple. Make it simple. Weight. Simple. It's weight, right? If the person is a fat, bulky person wants to become lean, slim, and trim, he will measure the weight. Simple one. Okay. Now, similarly, if a process has to reduce the variation, what parameter will you measure? Type in the chat box. What parameter will we measure? Follow. If the process has to reduce the variation, which parameter will we measure? Average step. Now you got it. We will measure a standard deviation or a sigma. Everybody write sigma in the chat box. S-I-G-M-A. Sigma. We will measure sigma. Sigma is a measure of variation. If you want to become slim, you have to measure weight. If you want to reduce your variation, you have to measure sigma. That is what we are measuring today. Everybody got it? Yes? Sigma of the temperature. That is right. But the standard deviation, which is sigma, we have to measure. Now let's measure the standard deviation. So let me just randomly take up some numbers. Let's say first cup, let's say 60 degree. Second cup, 65 degree. I'm just giving you random numbers. 85 degree. Okay. And then 92 degrees. 87 degrees. Okay, that's it. All right. Now, let's say I have taken 5 cups because I want you guys to make it manually. Okay. Chalo, can you just calculate the, or shall I make it a little easier? 85, 95. Chalo, thoda sa easier kar dete hai so that calculation will become easier. Let's make it 95. And let's make it 85. Okay, so everything I have just made it simple to calculate. Okay, with denominator of 5. All right. Now, clear? So these are the 5 cups. Now tell me, out of which only 85 will be actually accepted by the customer. 60 will be rejected because it will be too cold. 65 will be too cold, will be rejected. 95 will be too hot according to a specification, will be rejected. Only 85 will be accepted. Okay, anyways, coming back to the point. Now, once we collect the data, so then we take the average. Can you just make the average of this? Take average, which is X bar. Can you just calculate the average of this, everybody? Take the average of this. 60 plus 65 plus 85 plus 95 plus 85 divided by 5. Is it 78? Everybody got the same answer? 78, 78, 78. Yes? Okay, fantastic. So average is 78. Clear? Everybody's on the same page? 78. So it's all taking the summation divided by 5 is average. The first step is we have taken the average. Why we have taken the average? See, we are calculating standard deviation. We are calculating sigma. What is the name of the title of the today's session? Calculate your process sigma. That is what we are calculating right now. Okay. Now, once you have taken the average is the average line is a reference line. Okay. From where we will actually calculate the distance of each and every data point. For example, okay, what is the distance between 78 and 60? So, what is the distance between 78 and 60? So let me make it a little easier for you, okay? Let me make it easier. 60, 65, 85, 85, and 95. Okay, so I have just arranged in ascending order, all right? Now the average comes out to be 78. Now what I'm calculating, what is the distance from average and this data point and each and every data point, okay? So the first step is taking average. Now the second step is finding the deviation. Find deviation. What is deviation? Distance or deviation. Distance from the mean of each and every data point is called deviation. Now 60 minus 78 becomes minus 18 because 60 is a lesser number, right, than 78. So it is minus 18. All right. 65 minus 78 is minus 13. Then 85 minus 78 is 7. Again 7 and 13. Everybody got the same answer? Just give me yes in the chat box. These are the deviations. Everybody with me? So what I've done from the average, I have calculated distance. Some distances are negative, some distances are positive because they are on the left and right side of the average, correct? Now tell me, all right, now can you take, let's take the average distance, here. Can you just take the average distance? Say, yeah, 78, yes, barabar hai, yes. Anything missed out? No, right? Calculation barabar hai, 85, 78, 85, 78, yes. I think barabar hai, 78 and 90. 78 and 95. No, it is wrong, right? It is 17 and not, okay. No. Just a second. 95 plus 78 wala mistake, right? This is 17. Correct? Now it is right. 95 minus 78 is 70. Correct? Perfect. Now, can we check the average deviation? Just take the average deviation of this. Take the average of these values. So we are calculating the average distance from the mean. Minus 18 minus 13 plus 7 plus 7 plus 70. Find out the average of this. Type in the chat box. What is the number? What is the calculation coming? Is it coming 0? Why it is coming 0? Because minus and plus are actually clashing with each other and you are getting 0 out of it. Yes? So what these statisticians have done, they have started taking the squared value. Okay. What they have done, you don't take the direct average, you take the squared average. Okay. Why squared average? Because the squared value is always a positive value. Correct? So take square values of the deviation. Okay, first take the square values. That means minus 18 square. Okay. Then minus 13 square. 7 square will remain as it is, 7 square will remain as it is, and 17 square will remain as it is because it is a positive value, right? But again, we have to take the square of each and every value. Can you take the squared values of it? Now, it will require a calculator. Don't do it manually. It will take time. Okay. If you have Excel sheet, you can do it, or calculator. And now, tell me now the squared average. Okay. इसके बाद में you take average of the squared values. Okay. Take average of squared values. Yes. Now tell me the complete answer. You take plus minus 18 square, then minus 13 square, then 7 squares. Just do it once. Okay. Your funda should get clear. Today your fundamentals will get clear. It seems difficult because a lot of number crunching and mathematics is there, but not to worry. We have a software with us. You don't have to calculate it anytime, anywhere. The moment you feed the data, software will give us the value. That's it. Tell me, what is the average of this number? Is it 178 or 76? Sorry, 176? I'm just going by you. Very good. So this one, so the squared values total was, the numerator is 880 divided by 5 is 176. Everybody got the same value, 176? Very good. Now, because it is a squared average, let's take the square root of it. Let's take square root of 176. What is that number? Of 176. It will be 13.266, right? Everybody got the same value, 13.26. Now, whatever squared average we got, and this is called as variance. The step number 4 is called as variance, which is denoted by sigma square. And the step number 5 is called as standard deviation, which is basically shown as sigma, like this. Got it, everybody? So, very good. So, variance is sigma square and standard deviation is sigma. So, we have got 13.266. What is the unit of measurement? Let me give you the answer. It will be measured in degree centigrade because our data is in degree centigrade. Write this down. Standard deviation sigma has the same unit of measurement that of the data set. Make a note, very important insight. A lot of people say standard deviation does not have the unit. It does. Okay, same as the data set. It will be, if the data is in degree centigrade, it will be in degree centigrade. If the data is in centimeter, your standard deviation will be in centimeter, and vice versa, whatever. Clear, everybody? With me? Have you understood this? Just type yes in the chat box. Got it? यहां तक सबको समझ? Just take a screenshot if you wish. If you're not taking the notes, if you're traveling, maybe just take a screenshot. And I'm recording this anyway. You can refer the recording later as well. Now, so what have we? So let me summarize whatever we have done till now. Okay, we have not yet completed. Okay, first, what if we did not arrange the data point in ascending order? Does not matter. No, does not matter. So anyways, see, manually we are not arranging. Okay, manually we are not arranging, right? See why I have done it because just to make it simpler. Okay, that there was no other. So we need not to make the data in ascending, descending order. That is not required. Just for your simple calculation sake, I have just made it that way. Okay, that was the only reason. Now, let me summarize whatever we have done. So we were on the tea stall vendor. Tea stall vendor wanted to improve the customer satisfaction. So he collected the data for critical to quality parameter, so we understood the concept of critical to quality, which is important for the customer. So we identified taste, we identified the temperature, we identified the hygiene. Then we collected voice of customer, which is the rating, right? So test was 8 out of 10, hygiene was 9 out of 10, and your temperature was 6 out of 10. So we identified temperature as the area of improvement, and we took up a Lean Six Sigma project for that. Everybody understood? Just give me yes in the chat box. Understood? So why we have taken temperature? Because this critical to quality parameter was not functioning well, not doing well as far as the KPI is concerned. Now, so we started collecting the data. Now we have understood that if we have then after that we collected the voice of the customer and decided our voice of design, which is nothing but specification limit from the customer requirement, which is the range of acceptance 70 and 90 degrees. So customer would accept the cup of tea, between 70 and 90 degrees. Okay, so that is called a specification limit. Now we are collecting the data to check whether my process is fitting in that specification limit or not. Okay, and ideally what I have to do, I have to reduce my variation, and there is a measurement of variation which is called as standard deviation. So how do we collect the standard? How do we calculate a standard deviation? Those are the 5-6 steps which we have done right now. And our standard deviation is 13.26 right now. Everybody with me? Just give me yes quickly. I've just summarized last half an hour, 40 minutes. Clear? Just give me yes. Okay, you're connecting the dot. The same process happens in the real life example, in the real life industry. We have to select the low performing KPI. We have to collect the data. We have to check the standard deviation. And our objective is to reduce the standard deviation. Now, if this is 13.6, understand this. Let's say this process, just a second. This one, okay. If this graph is 13.2, let's say standard sigma 13.2, okay. So we have to reduce that standard deviation maybe to 8 degrees centigrade. So that as the variation will reduce, the standard deviation should reduce, just like when a bulkier, fatter person will reduce the weight, become the slim or trim, then that person's weight will reflect that, right? Maybe he might be 120 kilogram, now he will be 100 or maybe 90 kilogram. Okay, so kilogram, the weight is the unit of measurement. Similarly, standard deviation is the unit of measurement for our reduction of the variation of the process. So right now it is 13. We have to bring it down by using our DMAC framework: define, measure, analyze, improve, and control. Are you correcting the doc? This is how we do the project and reduce the variation. Okay, so we'll define this, we'll collect the temperature, we'll map the process, we'll identify why it is there, we'll go the cause and effect Y analysis, we'll identify the solutions, we'll implement the solutions, and by doing all these things, we'll reduce the variation and we'll bring the process to the center. So a lot of people will be happy, and our rating from 6 will go to 9. This entire loop is called the Lean Six Sigma project. Okay, now after this, let me go to the next part. Okay, which is called as your process capability. Now try to understand this. This is very important. If you can understand this part, your understanding of Six Sigma will become much deeper in this next 15 minutes. Okay, just try to understand this. Let me draw the same process of T, and we have 70°, which is called as lower specification limit and upper specification limit. So lower is 70, upper is 90. Okay, now imagine I collected 30 data points. How many? Minimum data you should collect is 30 data points. Everybody just type 30 in the chat box. But you have only collected 5 data points now for the calculation. Because we were doing manual calculation, that's why I only selected 5 data points. If I would have taken 30 data points, then you would have become mad to calculate manually. I wanted you guys to do it manually first. Okay, minimum 30. Why? What is the logic of 30? Just try to understand. As you collect 30 data points, naturally the data will take shape of normal distribution. Normal meaning symmetrical distribution. This is the bell-shaped curve, which is symmetrical. If I cut it into half, it will be exactly similar to each other, right? So this basically takes place above 30 data points. Below 30 data points, you may not get this kind of a shape. Okay, now how do you come to know exactly 30 after so many permutation combinations, R&D, research and development, etc.? Statisticians have arrived to this point of 30. Okay, now imagine we collect 30 data points. Okay, and we check the temperature of each and every 30 cups. Now in this point, our product is cup, right? Cup of tea, right? Now the temperature, we have got 30 data points temperature, and we collect the average. Let's say average is 80°. Understand this, huh? And standard deviation of that, now we are calculated 13, right? But here the standard deviation is, let's say, 5° centigrade. Okay, everybody understood? So I have collected 30 data points, 30 cups, and every cup temperature I have measured, and average temperature I have calculated. This is coming to 80° centigrade, and I have calculated standard deviation with the same process which we have just followed, and the standard deviation is coming out to be 5. All right, I have just randomly taken the number. Now tell me here, just focus here. Now this is very important point, just focus here. So let me just put, so let's say my average X bar is here 80°. So how many standard deviations? So 5° is one standard deviation. So within this X bar, which is this dotted line, and my upper specification limit, okay, how many standard deviation I can fit? If you see very clearly, if this is sigma 1, which is 5°, and this is sigma 2, which is another 5°. So how many standard deviation I can fit between X bar and USL? How many standard deviation I can fit? Type in the chat box. Everybody, just think about it. USL is 90, X bar is 80. How many sigmas I can fit? 2 sigmas. Are you understanding this? I can fit 2 sigmas between my upper specification and my X bar. Everybody understood this? Just type yes in the chat box. Total 4. But between my USL and my X bar, I can fit 2. Yes? Everybody understood this? I repeat again. My USL is 90, my X bar is 80, which is average of the 30 data points, and my sigma is 5. So I can fit between 90 and 80. That's a total is 10. Within this 10, I can fit 2 times standard deviation. When I can fit 2 times standard deviation, that's where my process is 2 sigma process. Just type yes if you have understood this. If I can fit 2 times standard deviation between my X bar and my upper specification limit, that's where I call it as 2 sigma process. If it is 3 times, that is called as 3 sigma process. Are you clear? Just stay with me. Stay with my statements and just type yes in the chat box. I repeat again. If I can fit 2 times standard deviation between my X bar and my upper specification limit, I will call it as a 2 sigma process. Just give me yes. जिसको समझा है, just type yes. Don't think anything else. Just stay with my statement. Just stay with my statement. I repeat the statement again. If I can fit 2 times standard deviation between my X bar and upper specification limit, I will call that process as 2 sigma process. Okay. The formula is, write down the formula. Let's make it simpler now. This 2 is called basically process capability. Yeah. Formula is Z is equal to, this Z is nothing but it's a process capability number. I call it as sigma number. Okay. The formula is USL minus X bar divided by standard deviation. Let's put the values here. USL is 90 degree. X bar is 80 degree. My sigma is 5 degree. So 10 divided by 5 equals to 2. When my Z score is 2, that is called as a 2 sigma process. Just take down this. Have you taken this formula? USL minus X bar divided by standard deviation. USL is 90. X bar is 80 divided by 5. 5 is our standard deviation sigma. So 10 divided by 5 is equal to 2. When my Z is 2, that is my 2 sigma. The same thing. I can fit 2 standard deviation. That's where my Z will be 2. Just type yes if you have taken down this. Okay, everybody with me till now? Very good, very good. Now listen to me very carefully. Listen to me very carefully. Now we implemented DMAC principle on the variation. We'll ask the question, what are the man causes of variation? What are the machine causes of variation? What are the measurement causes of variation? What are the material causes of variation? I will find out the causes. I will find out the root causes. I will take some action and I will reduce the variation. Now imagine the variation has reduced. Let me draw this again. Let me draw this again. Just a second. Now this is the same process standard deviation. Okay, the same process. Now the variation has reduced like this. Okay. So same 90 degree, 70 degree. Now let's imagine X bar is 80 only. Okay. So now if the variation has reduced, what will happen to sigma? This standard deviation, will it increase or will it reduce? What will happen to this standard deviation? This one. Will it reduce or will it go down? Go up? Will it increase or will it reduce? Type in the chat box. What will happen to standard deviation? When my variation reduces, what happens to my standard deviation? It goes down. Everybody, I want everybody to think about it because these are fundamentals. It's very simple. When the fat person reduces his fat, the weight goes down. Similarly, the variation of the process reduces, the sigma goes, the standard deviation goes down. Standard deviation, sigma, will go down. So from 5 degrees centigrade, imagine if your variation is reduced, let's say it has come to 2.5 degrees centigrade. Okay, now it has reduced to 2.5 degree. Now what will be the Z value right now? Just calculate the Z value. USL minus X bar divided by standard deviation. So USL is 90 minus 80 divided by 2.5, which is Z will be 4. So when the Z score is 4, that is my 4 sigma process. Similarly, if I reduce it further, the moment I can fit 6 times standard deviation, that becomes my 6 sigma process. So when I say 6 sigma, just try to understand this. When I say 6 sigma, this sigma represents standard deviation, which is variability, which is basically variation. Variability, let's say, let me write variability. And this 6 represents the process capability, the Z score, right? Which is representing process capability. Okay, so this 6 is a Z number and the standard deviation is a sigma number. So what our objective is to reduce the standard deviation to increase the Z value. So from 2 to 3 to 3 to 4, 4 to 5, 5 to 6, that is how we have to increase our Z number. That is the objective of this. How many of you got it? Just type yes in the chat. I understood this after 3 days. When first this concept was explained to me. It took me 3 days to understand this. If you are understanding it first attempt itself, you guys are amazing, brilliant people. Super IQ people. Understood everybody? Simple. Yeah, why not measure the mean to LSL instead of USL? We can do it either of this. We can do it to this one as well. You can do it for LSL as well. LSL से भी आप कर सकते हो. Okay. Just for, so that means when it is a 6 sigma process, okay, understand this, huh? When it is 6 sigma process, I can fit 6 standard deviations. So 1, 2, 3, 4, 5, and 6. I can fix 6 standard deviation between my USL and my X bar. Everybody understood this? Between my USL or X bar, I can fit 6. If I can consider USL and LSL, I can fit 12 standard deviation between my USL and LSL. Then that is called as a 6 sigma process. That's my assumption, Satishji. Sigma value 5, that's what we have calculated. No? So we collected 5 cups. We calculated the standard. What is standard deviation? What is sigma? Is the average deviation from the mean. Simple. Okay. So yes. So in earlier case, it was 13.2. That was the standard deviation. Now, why I have taken 5? Just for sake of simple calculation. Okay. Now, can we calculate it for 13.2? Yes. Very good. Yes. Can we calculate for 13.2? So our 90 and 70 is same. Our sigma is 13.2. Can you calculate the Z score for 13.26? Just calculate this, everybody. Same example, 90 and 70, correct? Let's say X bar is 80. Can you calculate for standard deviation 13.26? Type in the chat box. What will be the Z score? Z value क्या आएगी? Is it 0.75? Or around 0.75? I don't know. Just calculate it. So what will be the value? 90 minus 80 divided by 13.26, same thing. So 10 divided by 13.26, whatever is the answer, that will be the value. What is the number? 0.75. So my process is right now 0.75 sigma process. Clear, everybody? Zero 0.75 sigma process. Clear? Any process which is less than 4 sigma process is not a good process. Okay. Any process below 4 sigma process is not a good process. You have to go beyond 4 sigma process. Always remember this. Everybody with me till now, just give me yes in the chat box. Understood how the entire Lean Six Sigma methodology basically works, the fundamental, what is sigma, how it has to be calculated. So for you guys, first you decide which CTQ you want to improve. Okay. So first you decide which CTQ you have to improve, collect the data, set the specification limit, check the standard deviation, calculate what is your current process capability. Okay, so this is called as process capability analysis. This Z-score is a process capability. So we check the process capability twice, one in the measure phase and later in the after improve phase, which is in the control phase, you can say. Okay, so in measure phase and control phase, 2 times we calculate. In the measure phase, we check what is the current process capability. And in the control phase, we check the improved process capability after improved. Okay, then we compare and we want to have some improvement. Let's say current process capability is 2 sigma. We want that 2 sigma to become 3 sigma or 4 sigma. That is our objective of doing this exercise. And we do DMAC framework. We use DMAC framework to take the process capability to the next level. That's how the entire Lean Six Sigma works. Clear? So how many of you, your understanding has gone to the next level today? Just type me in the chat box. Very good. Everybody, the new members especially. Yes. So this is how every live session, we take the basic concepts. Yeah. Can you repeat which sigma value will be acceptable? 4 sigma and above. So always try to reach to 4 sigma level, at least 4 sigma level. Okay, you will find that your current process capability is a little lesser than that. So at least try to make it beyond 4 sigma. Okay, as we go in the next levels, you will understand why 4 sigma I mentioned. Okay. Clear? Any question on the today's session? Just type that question in the chat box. I'll answer that. Okay, so come to the live sessions. All the recordings of the live session, as I mentioned earlier, are available in Masterclass Archive. Okay, so all the new members, I'll show you. Yeah, every time I am new, because every time you have encouraged us. Okay, thank you very much. Yes, and you have been very consistent. I must appreciate that, Kiranji. Okay, because it is very difficult to manage. See, today is working day, Monday. Your travel, your office, I can understand. And attending the live session consistently requires a lot of discipline, which you guys are showing. Amazing. Even Maheshji also very consistent. Standard deviation decreases, process capability increases. Absolutely right. So when I say, so just to summarize this, in the nutshell, when let's say I'm at, 3 sigma process. So what I will do, I will decrease this standard deviation. As my standard deviation goes down, my process capability sigma will go. Now I call it as sigma. Okay. So I name it as sigma combination. Just to remember this rhyming, sigma, and this is sigma. So you reduce the sigma to increase your sigma. There is no technical term called sigma, by the way. Let me clarify that. Just to make it a rhyme, because we remember rhymes very easily, na? So remember sigma combination. So when I say, when I say 6 sigma, that sigma is the standard deviation, and 6 is that sigma number. That's why I call it as, so sigma denotes variability, and sigma denotes capability, process capability. Okay. So our role is to reduce variability to increase process capability. That is the summary of Six Sigma method. That's it. Super. Thank you very much. That's it for today. Just contemplate on this. All the new members, check the recording, which will be uploaded after some time in the masterclass archive. Just check the recording. You can increase the speed as well. Okay. And just contemplate, take your own data, calculate the standard deviation, calculate a sigma value. Okay. So that you will understand your own process capability. Clear? Yes? So that's the homework for you guys. We'll connect in the next class with the new topic, but with the same enthusiasm. Till the time, keep learning, keep growing. Tata, bye-bye, good night. In between, if you have any query, as I've given you the number, the WhatsApp number of the mentor, please stay connected on that, send the message, and we'll be there to support.